Okay, in this video, I'm going to introduce you into a different method in determining whether the argument is valid or not valid. That means that we will not use the truth table here, and we will not use also the valid argument forms as shown in our previous video. So let me show you another method that you may find easier to use. Okay, first convert the argument in symbolic form. So again, here we have K implies S, and then I didn't see my glasses at breakfast. That would be negation of S. Then your conclusion is therefore negation of K. So question is this valid or not? Okay. This method works under the assumption that your premises are true. Okay. So that means that negation of S, which is a premise, is true, right? So that's considered to be true. If negation of S is true, then that means that this is false. Okay? So negation of S is true, being a premise, implies that your S is false. Now take note that K implies S is a premise, which means that being a premise, this must be true. So if this is true, and your conclusion here, your S, the consequent is false, your K cannot be true, right? Because if your K is true, then true implies F is false, which contradicts to the idea that this is a premise. So if this is false, there's no other conclusion but to say that your K is actually false, because false implies false is true. So again, it cannot be true, because if this is true, then this statement is false. Okay, if your K is false, what about your negation of K? Your negation of K, of course, is true. Okay, so therefore, you have a conclusion which is true whenever your premises are true. That's why this is a valid argument. Okay, I hope you're getting the idea. Okay, letter B. What about letter B? Okay. Again, by the way, this method works especially if you have a premise that contains only a single variable. No? Okay. So M being the premise, being a premise is true. That means that M here is true. Again, you have M implies negation of N, where M is true. In order for this to be true, being a premise, take note your negation of N cannot be false, because if this is false, then true implies false is false, right? So this should be true. There's no other way but to conclude that this must be true. Okay, in order for this to be true. Now look at your conclusion. Negation of N. But what is negation of N? Negation of N is true. So you see, negation of N is true whenever your premises are true. Therefore, this is valid. Third, you have again a negation of H being a premise. This is true. But if negation of H is true, what do you say about H? That's actually false, right? Okay, if this is false, take note that you have H or J. H or J is your first premise, which is supposed to be true. But since H is false, what do you say about J? You have no choice but to say that J must be true. Because if J is false, then your first premise is false, which is inconsistent with the idea that the premises must be true, right? So your J must be true, and your conclusion is J. Now what is J? J is true. So therefore, you have a conclusion, a true conclusion, when your premises are true. So you have again an argument that is valid. Okay, next example. Let's convert this again into symbolic form. You have M and E. Okay, you only have one premise here, and your conclusion is Abraham Riemann is an engineer, which is E. Okay, you only have one premise. Of course, a premise must be true. But when is this true? This is true. Conjunction of M and E, no, is true whenever M is true and E is true. Because if only one of them is false, then you have a false statement. But since this is a premise, the premise must be true. That's why M and E must be true. We can conclude here that your E, being your conclusion, is true. So you have a conclusion that is true whenever your premise is true. So again, you have a valid argument. Okay, for our next example, if you can read this book, so that's R, you can go to college. So implies C. You cannot read the book. That means you have negation of R. Okay? Therefore, you cannot go to college. That means you have negation of C. So is this a valid argument or not? Again, we start with the second premise, negation of R. Being a premise, this must be true, right? If this is true, then that means that your R is false, right? Now, if your R is false, is it necessary for C to be true, or is it okay also for C to be false? Actually, your C can be true because false implies true is true. But not only that, your C can also be false because false implies false is still true. In other words, you have a case here where the truth value of C can be true or false. Now look at your conclusion. Your conclusion is negation of C. But if C is either true or false, that means that your conclusion, which is negation of C, is also either true or false. So you have a case here where you have two truth value for your conclusion. In other words, your conclusion in this case can either be true, it can also be false. So therefore, it is an invalid argument because you don't want your conclusion to be false. Also, although there is a case where your conclusion can be true, but there is also a case where it can be false. That's why this is an invalid argument. And last example, you have D, if it is difficult to obtain, implies L, can last long. And then your second premise is it can last long. So that means that you have L. Therefore, it is difficult to obtain, which is D. Okay, again, is this valid or not? Start with L. Being a premise, L must be true, right? Which means that L here is true. Now look at D. Is it necessary for D to be true? In order for D implies L to be true? Yeah, D can be true, but suppose D is false. Is D implies L still true? Yes. D implies L is actually true even if D is true or false. So again, you have a case here where you have two truth values for D. And now look at your conclusion. Oh, your conclusion is D. But your D can either be true or false. So, what do you say about the argument? The argument is invalid because it is possible for your conclusion to be false even if your premises are